Well, in our last episode, we learned how the transit of Venus was used to calculate one astronomical unit, the distance from the Earth to the Sun. Today, we're going to have a look at an actual observation of a transit of Venus on the 5th of June, 2012, from a site in Princeton, New Jersey, and another in Hawaii. So, cue up the music, and let's see if we can figure out how far it is to the Sun. Now, in closing, I'd like to go over this paper by Robert J. Vanderby. It was a very interesting paper to me because it had all of the mathematics in it, and it sparked my interest in looking at the transit of Venus. Now, Dr. Vanderby was in Princeton, New Jersey, in the North Parking Garage, and his associate was on a mountaintop in Hawaii. And they took these two very interesting photographs. Now, they were able to coordinate these photographs, so they were taken at exactly the same time. So here is the Princeton University photograph, and here's the photograph from Hawaii. As you can tell, they are slightly off, just like the other one was. That's the parallax angle. Now, to calculate the parallax, what he did was he normalized the images, lined up sunspots to sunspots, and made sure that the size of the images were the same. And then he counted pixels to the center of each of those images of Venus. And he found the distance between the two. It was 26.3 pixels. Then what he did was he looked at the width of the sun, and he converted the number of pixels to arcseconds. Here's him lining up the sunspots to make sure everything lined up properly. This is the measured parallax that he was able to get. He took the measured parallax, 26.315 pixels between the two silhouettes of Venus, and came up with 9.823 times 10 to the negative 5 radians. That's the separation between the two. Now, this has to be corrected because the sun itself has a little parallax. If you were to take your two observers and look at the silhouette of Venus, it's going to cross at Venus. However, if those same two observers looked at the center of the sun, it would cross at the center of the sun. That's the solar parallax. And that has to be taken into account for an accurate measurement. And he was able to do that, and here's his mathematics for it. And as you see, he went from 9.823 times 10 to the negative 5 radians to 1.373 times 10 to the negative 4 radians. So it went up a little bit. Now he looked at the distance between the observers in Hawaii and Princeton, used that to find the sine of the angle, and that creates the baseline. So even though the land distance is 7,835 kilometers, the actual chord distance between those 2 points, the baseline, is 6,007 kilometers. With that, he was able to calculate the distance to Venus by taking the base distance divided by the parallax angle. And that gave him 43.75 million kilometers. And as we stated, and by the way, here's a nice image of the overlapped Venuses. So he took the center here to the center here, counted the pixels, and that's how we got the mathematics. And here's an outline of what he did. There's his locations. And since he measured the distance from the Earth to Venus at 43.75 million kilometers and divided it by the fact that it's 0.2887 astronomical units between the Earth and Venus, he comes up with a distance for one astronomical unit of 151.5 million kilometers. Here's the same calculation from the 2004 transit. And as you can see, the official distance is 151.06. He came very close. Now remember, that's a mean distance as well. So it would have to do with what the actual distance on the day of the transit was, and that could be a little bit more or a little bit less. It appears as though it's slightly long, but the difference between the actual distance and his calculated distance was on the order of less than 1%. So that's not bad. I'm going to put a link to this paper in the description of this video. I think you'll enjoy it, even if you're not a real big math person, because he really takes it step by step, and he's got great illustrations. It's only about a 10-page paper. It's on PDF. Very easy to go through. And that is the Great Transit of Venus. Parallax is a wonderful measurement because we can also do parallax to the stars, and that'll be the subject of our next video in this series. So this is Bob the Science Guy signing out from Northern Michigan. Thank you very much for stopping by. I do appreciate your support of this channel. Remember, we have memberships and Patreons. So anything that you're inclined to offer will be deeply appreciated and will go into new equipment for the channel. I just bought a Link A12 bubble sextant, and I'm in the process of cleaning that up and refurbishing it. And we'll be taking some readings with that in the near future. So take care, guys.
Mama, please make them hear me, or I can't teach them anymore. This rabbit hole's too deep for me. Feel my brain getting real sore. Bob the Science Guy. Bob the Science Guy.